In this lesson, we're going to start looking at probability, and we're going to pull in at the end some of what we've learned from combinations and permutations so that we're able to find a complete picture of what our chances are for a given event. So first off, a little review of what probability is. The probability of an event is a measure of the likelihood or chance that this event will occur. When we work with probability, it's going to fall somewhere between 0 and 1. When you write it in your homework, even though all the answers are in fraction form, you have 3 ways you could write your answer: as a fraction, as a decimal, or as a percent. So here's kind of a spectrum of likelihood. So if something is deemed to have a probability of 0, we would say it is impossible. So if I were to put everyone's name in a hat for our class and then say, what is the probability that someone in this room is over the age of 100? Well, none of us are that age. Thus, it's not possible to draw someone out. So that would be a probability of 0. On the other end of the spectrum, if something has a probability of 1 or 100%, that means it's certain. It means it has to happen. So if I want the probability that I put everyone's name in a hat and I draw out someone who's less than the age of 100, that's everyone. Everything else kind of falls in between. If something is at a 50%, the word we like to use, or the words, are equally likely. If a value falls between 0 and a 50%, then you have something that is unlikely to occur. If it falls between 50% and 100%, or 0.5 and 1, then we say it's likely. And it's pretty typical to refer to these terms. Like if I told you there was an 80% chance it would rain, you're going to be like, all right, that's likely. I'll probably pack a jacket and maybe an umbrella. If I tell you there's a 10% chance of rain, you're going to be like, meh, it's probably not going to rain. So we kind of figure out likelihood based on where it falls between 0 and 100% or 0 and 1. So here's how you actually calculate probability. When you're asked to find a probability of an event, so the event is labeled here. So we're just going to call this event A. So this is our event. Let me kind of point that out. That event occurring is our favorable, meaning we want that to happen. This favorable will always be given to you. Let's say, what's the probability of you drawing a red marble out of a bag? They're always going to state what this is. So the top number is the number of favorable outcomes. I typically just shorten it down and say favorable. However, depending on how many outcomes are possible, you'll then divide that number by the total number of possible outcomes. And that's how we'll find our probability. All right, so let's put this to action. So here the event we have is spinning a spinner. It is equally likely to land on any of the sections, meaning it's not weighted toward one section. All of the pie sections here are all of the same size. So each one has an equal opportunity of being landed upon. So we would like to find the probability that the spinner lands on red. This is our favorable. So how many spaces on our spinner are red? That becomes our favorable outcomes. So a favorable outcome would be here, 1, 2, or 3. So we have 3 spots where red is favorable. However, we want to know the total possible number of outcomes. So if we just add up all the possibilities, 1, 2, 3, 4, 5, 6, 7, 8, we have 8 possible outcomes. So the probability of landing on red is 3/8. That is one way you could write your answer. The next way you could write it would be just to make it a decimal. In this particular case, this equals 0.375. And then lastly, you could write it as a percent, which is a very popular way to understand the likelihood of something. So if we put it in percent form by moving our decimal over, we would say there's a 37.5% that you spin the spinner and it lands on red. Now, we call this theoretical probability because it's in theory. If we sat here and spun the spinner a whole bunch of times, or let's say just 8 times, would it land exactly 3 times on red? That could vary. But in theory, the probability of getting red would be 37.5% or 3/8. All right, so now let's try this again. Our total stays the same, so I'm going to erase out my favorable here. So we still have 8 spaces, but now we want to know what's the probability of landing on blue. So our favorable has now changed. So the probability of landing on blue equals, so we have 2 blue spaces, 1, 2. So there's 2 favorable outcomes out of 8 possible outcomes. So our probability is 1/4, or you can write this as 0.25 or 25%. Now you don't need to write all 3. If you don't use the fraction form, just divide out the answers I have on the answer key, and that should get you to your percent and decimal. All right, last but not least, probability of landing on white. None of our spaces are white, so the possible outcomes of getting white is actually 0 out of 8. So this is an outcome that's impossible, so you could write your answer as 0 or 0%. And that is pretty much as straightforward as it can get. Theoretical probability, our favorable outcomes divided by our total possible outcomes. However, if we want to pull in the lessons from 10.4 and 10.5, sometimes we can use combinations and permutations to assist us in creating our sample space or our total number of outcomes. So let's look at that here. You have 8 songs on your workout playlist. You set your player to play all the songs on the list in a random order without repeating any songs. What is the probability that the songs play in the exact opposite order they are listed in the playlist? So since we're going specific for a very specific order, this tells me we're dealing with permutations because order is important. So our favorable outcome is to play in the exact opposite. So there is one way for it to play in the exact opposite order. Our total number of outcomes take us back to our 10.4 lesson. How many songs are we picking from and how many do we get to pick? So if we're looking at this, we have 8 songs and we are listening to all 8 songs because we want a list of all of the songs in the exact opposite order. So you could, since these numbers are the same, you could just do 8 factorial, or you could put 8p8 into your calculator. and you get 40,320. So if we build out the proper probability, so we're doing the probability that we have the exact opposite order. It's favorable over total, so 1 over 40,320. Now, if you divide that out into a decimal percent, it's pretty small, so it might be easiest just to leave it in fraction form. But if you would like to put that into a percent, you can. All right, last but not least. So now, still the 8 songs, but 3 of the songs on the playlist are by the same group. We want to know what's the probability that 2 of the songs by this group play first in any order. So in any order means we are now dealing with combinations. All right, so now let's look at our favorable versus our total. So favorable in this case is that 2 of the songs by our group play first.